All right, so 10-2 ellipses, you're just looking at two more formulas. So here's one. Tell me what this formula reminds you of. Something that is familiar to you that can help you remember it. Circle formula, right? Because it does have the h minus k squared and the y minus k squared and a plus. And both of them have the same thing up top, don't they? What's the difference between these two formulas? The placements of A and B. Okay, and it very specifically, they're placed differently for a reason. So let's go ahead and go through these so that you know what's what. But if you can think of an ellipse, actually kind of looks like a squished circle. It's an oval, right? So the fact that it resembles a circle formula makes sense, doesn't it? Okay. Also notice that this right side 100% of the time will be 1. If it's not, I'll show you how to fix it. All right, so for the first one, there's a bunch of information that you need to know or gather. But again, am I real big on memorizing all the minor formulas that go with this? No. I'm going to go ahead and give them to you just so for people like Caitlin, who needs to see them, wants them. But for the rest of you, I'm going to rely solely on my graphing in order to find things like vertices and foci and that kind of thing. So for this one, notice that A is really important. First of all, A should always be greater than B. So A is your bigger number out of the two. For both of those, A is always greater than B. So the fact that A is underneath the x squared is important. A over here is underneath the y squared. So if A here is underneath the x squared, doesn't x go in this direction? So ellipses have what's called a major axis and a minor axis. The major axis is the longer part of the ellipse. The minor axis is the width of that ellipse. It's always a smaller distance. So for this one, this has a horizontal major axis. Because the a squared, she asked, how can I tell? So the a squared is underneath the x squared, and doesn't x go in this direction? And so that's horizontal. My vertex is, what do you think? My vertex. So my vertex, see down here we have center? Center, I guess it's not a vertex. We call it the center. We have other things called vertices. So your center, just like on the circle, is HK, just like the vertex on the parabola, right? So that's easy to find. And again, it's the opposite signs. Your major axis here is always the distance of 2a. So to get 2a, wouldn't I take the square root of this denominator and double it to get the whole distance of the major axis? I rarely will find the whole distance of the major axis. I only care about half of it. Because once I have the center, then my major axis will be half in this direction, half in that direction. My minor axis would be half up and half down. What do you think my minor axis is going to be? To be or not to be? That's the question. That's a funny one. You all are not laughing. Come on. It's the last period of the day. And again, you will rarely see me finding the whole 2b unless I'm asked to find it. I'll just usually find b. So usually I'll just find the square root of this and the square root of that, and that'll tell me the lengths that I'm going from my center, up, down, right, and left. All right, and then we have this thing called C and a focus and this eccentricity down here. I'll talk about those as I graph it. So let's just look at this one. And let's go ahead and graph a center at 0, 0. And then I'm going to go out I'm going to go 6 to the right, 6 to the left, and then up 3 and down. So when they ask for vertices, your vertices, I don't ever use this to find them, but here's the formula if you want them for vertices. For this particular formula, vertices are going to be going along the x-axis. So from the center, won't the x value of the center change to get to this left vertex and to get to this right vertex? Is my k changing up or down? No. So we end up with h plus a, and it's the same a as here, because we're going only a to the left and a to the right, and then k. Or h minus a, k. So my vertices, I'm going to go out 1, 2, 3, 4, 5, 6. And to the left, 1, 2, 3, 4, 5, 6. So if the distance from the center out to one vertex is 6, what is a squared going to be? 36. And then I also call these vertices, but if you're asked to find all 4 vertices, then you're going to include these as part of the 4. Otherwise, if they just ask you to find vertices, they're probably only looking for 2. If you give me all 4, that's fine. So if you want to be on the safe side, give me all 4. But if they just ask for vertices, they're generally looking for only the major vertices, which are along the major axis. So we're going to go up 1, 2, 3, plot a point, and down 1, 2, 3, and plot a point. So this distance from here to here is b. So if b is 3, what's b squared? 9. And if my center is 0, 0, what would this equation look like? What's x minus 0? X. So wouldn't this be x squared over 36 plus y squared over 9 equals 1? There's the equation of an ellipse going with its center at the origin. Okay, I have a little problem now. Bear with me. So it looks like a little football, right? Got a little deflated there. Oops. So then we have to put in the foci. And your focus is always c distance from the center. So you might want to write down here that foci lie on the major axis, c units from the center. So we have to find c. So this is the only other part of the formula you have to memorize. So here's the things you have to know. You have to know how to find a and b, so you just take the square roots of these denominators. You have to know that the bigger number is always telling you which axis your major axis is on. So a is always your bigger number. Since a is underneath the x-axis, that's how I knew my major axis was going along the x-axis direction. It doesn't mean your center is always at 0, 0. Then you have to know where to put your foci. Your foci, like in the parabola, it's inside the ellipse, and it's always also on the major axis. So your foci are going to be like here and here. But they're a certain distance away from the center, and that distance is c. So we have to find c. You've got to memorize this other part of the formula. But what does it look like to you? It looks very much like the Pythagorean's theorem, but it has a minus, right? When we see hyperbolas, you're also going to see c again, and you'll see a slight difference. So for here, we'd take this, subtract this, and take the square root, and that would give us our foci. I will go ahead and give you the formulas to find that, so you can write it down here. So your foci, and again, I don't memorize this because I'd rather just graph it. Again, your h or your x is going to be affected, so you're going to subtract c or add c, but the k doesn't change. And then we have this thing called eccentricity. Eccentricity is, it really measures the ovalness of the ellipse. The more fat the ellipse is, the closer it approaches a circle, right? The more narrow the ellipse is, the closer it approaches a straight line. And so the eccentricity can tell you, we don't really do a whole lot with it, but you're going to find it. And I want you to compare in your problems, both from the notes and your homework problems, compare that eccentricity and compare the shape of your graph and see what it does. So your eccentricity is going to take E for eccentricity is C divided by A. So the same C that we found for the focus divided by the A, which is your half your distance of your major axis. And then you might want to put on here for your notes, it measures the ovalness of an ellipse. Yeah, I know, you just learned a new word, ovalness. Sure. I don't think you did eccentricity last year. Some of you might have graphed ellipses. Some of you have not. You might have, like I think Nelson did. All right, so then this one, the only thing that's changed is the A and B are in different spots. So now the A squared is underneath the Y. So that means that your major axis is going in the direction of the Y axis, so it's a vertical major axis. So over here, so again, I'm going to go this time, I think I'll do the same thing, 6 up. And then 3 to the right, and 3 to the left. And so for this one, my center is going to be at the origin. My vertices are 6 up, 6 down, 3 right, 3 left. I have trouble making ellipses. So I always have a deflated side. Where are my foci going to be? Along the y-axis, right, or the major axis here. Just to let you know, these vertices, your equations for the vertices for this one, what's changing from the center? Your x value or your y value? You're going up and down, so is that your x value or your y value? Your y. So for your vertices, you've got h stays the same, but your k, you will either add a to that, or you will subtract a from that. And so for your foci, again, your h is going to stay the same, but your k is going to be affected by what? Yeah, your k, you're going to add your c or subtract the c. Now that's going to be important to know this actually. If I ask you to write the ordered pair of your foci and your distance for c is like the square root of 5. We'll talk about what to do with that. Yes?
Is that on the H or on the
Where? Here?
The vertices of the horizontal. And the other ones.
Those are k's. Those are h's.
And the other ones.
A's.
On the horizontal. A on the other one, the horizontal. You have K minus an A.
On this side, on your. There we go.
Exactly.
Oh, thanks. Gotcha. No, that's just an H. I didn't even realize I did that. Thank you. I'm like, what are you people talking about? Okay, Kelsey, mark me up for 1. I know you did. Okay, so we've gathered, I've told you all the information that you need for an ellipse. So really all you have to do is know the standard form for either one, and they're exactly the same except the a squared and b squared changed. You have to know that the reason for that change is it tells you where the vertical or where your major axis is, whether it's vertical or horizontal. Think in terms of the same direction as the x or the y axis depending upon what it's under. Then the other thing that you do have to know is what I've highlighted here, how to find c. The rest of it you can do from graphing. So let's look at example 1. You are to graph, find the center, the 4 vertices, the foci, and the eccentricity. So this is in proper standard form. I've got a 1 here, right? So which one of these is A? Yeah, so our a squared is here, so it's underneath our x, so that means that my major axis is going to be horizontal. So just for my own personal, so I remember what's going on and I don't make a mistake, sometimes you might put your foci on the wrong axis because you're not thinking. So your horizontal axis is your major. So that should be the longer one. So can't I see my center from here? What's my center from here? 1, 2. So I'm going to plot that point to the right 1, up 2. There's my center. Then I'm going to find A. So this was number 1. Then number 2, I'm going to find A and B. So A is equal to what? Take the square root of 25. 5, right? Because my horizontal axis is major, I'm going along the x-axis. Don't I want to go right and left with that? You can memorize the little formulas for the ordered pairs if you want to, but why? So I'm going to go 5 to the right. 1, 2, 3, 4, 5. Caitlin, you want to grab one of these out of here? That top folder. And then 5 to the left. So there's my vertices. Well, 2 of them. And then step 3, what do I want to find? B. So how do you find B? Square root of 16 is 4. So up 1, 2, 3, 4. Down 1, 2, 3, 4. Aren't your axes pretty close to the same length? So this is going to be a pretty fat ellipse, won't it? Almost close to a circle. So compare that eccentricity to a real narrow one when you get one. So I'm going to go ahead and sketch that in. Looks like that kid's face on the Rugrats. Is that what it is? No, is that what it is? Arnold? Okay. Yep. Tommy? I wouldn't let my children watch that show, but neither here nor there. Because that kids are smarter than the parents in that show. In my household, the parents are smarter than the children, just saying. All right. Question. Question.
How do you know 25 is A?
Because the bigger of the two, remember A is always bigger than B, so the bigger of the two is your A squared. And then because it's under the X, I knew I was going in the direction of the X-axis. Good question. So then what do I still have to graph on here? I've found my center, my 4 vertices, foci. So step 4, I would like you to write the ordered pairs of your foci, but we've got to find it. What do I need to know to find it? C. So we're going to use C squared is equal to A squared minus B squared. The more that you write it, the more likely you are to remember it. So what we're really doing is, my A squared is already 25. There's no need to put 5 in there, right? And my B squared is already 16. So what does that equal? 9. So C squared is 9. Take the square root of both sides. We don't need a negative because we wouldn't have a negative distance. Doesn't C equal 3? So from there, I'm going to go to the right 3 from the center and to the left 3. So it's always from the center. Think C center. So to the right, 1, 2, 3. And to the left, 1, 2, 3. And please label them with little f's. And then I would like you to write the ordered pairs. Name that ordered pair, please. So that's 1, 2, 3, 4, 2. And negative 2, 2. So there's our foci. We have our center. If they asked you to name the vertices, I would, and just to be on the safe side, if I were you, I would name the vertices. Label those ordered pairs, especially when you're taking a quiz or a test. Then what's left? Eccentricity. So last one, 5. Eccentricity. So E is equal to C over A, which is equal to 3 is C, and 5 is our A. So eccentricity is equal to 3/5 or 0.6. I don't care if you give me the fraction or the decimal. It's easier to compare the decimals than it is the fractions. That wasn't so bad, right? It doesn't get any harder other than writing the equation. Yes. So far I haven't really needed a calculator, have we? I mean, if I think that you can do the calculations without one, then no, you won't have a calculator. Mostly because the calculator will graph them for you. If you haven't found that, there's a little formula in there. There's a little thing where you can graph conics. That's the reason why you're like, what? That's the reason why you won't be using a calculator. Okay, so this one, what's wrong with this? Oh, now remember what your standard forms look like, right? So our x comes first and then our y's, but they're all on the same side. So I am going to take, here's an x and here's an x, those go together. And then here's my y's, those go together. And doesn't the 31 have to go over to the other side? It's constant. We'll get that to be 1 in a minute. So how do I get it into a nice parenthesis squared? Complete the square. So we've got 9x squared minus 36x plus blank, and then plus 4y squared plus 8y plus blank equals negative 31 plus blank plus blank. Can we complete the square with a coefficient in front of the x squared? No. So we're going to have 9 parentheses. We have to factor out a 9 from just these two. So I get x squared minus 4x plus blank. Then I have to factor out a 4 from these two. So plus 4 times y squared minus 2y plus blank equals negative 31 plus... Y is what minus?
2y.
Plus 2y. Just testing you. No. I'm sure Kelsey is. All right. Then complete your square. Do you need a reminder on completing the square? Remember, c is equal to b over 2 squared, and c is not representing c in the distance the foci is from the center. It's c as in the constant here. So I'm going to add a 4 here, right, to complete the square, but I don't add a 4 here. Why? What do I actually add? I'm taking it out of the parentheses, so I do have to multiply the 4 times the 9. So if I were you, I would put here 9 times the 4, so you remember where that 36 came from. Don't just put 36 in your notes because you'll forget how did I get that. Then complete your square here. Make sure you multiply it by 4 before you put it on that blank. So again, I'm doing 4 times 1, right? So then I have 9 parentheses squared. What goes in here? Your middle, bless you, your middle term is a minus. So isn't it x minus 2? Plus 4 times, what goes in here? X plus 1 squared equals
Y.
Thank you. Equals, good gracious.
That's how angry you sounded.
Good gracious, I know. That was like an electric shock, like shock therapy to the teacher.
She's messed me up a few times today already.
She's on Benadryl. She's a little crabby.
I know.
All right, so we have negative 31, and then both of these are positive, right? So I've got 36 and 4. What does that give me? 40. So I've got a 40 and a negative 31. Doesn't that give me a positive 9? No, that can't be. Something's wrong. Oh, I know why. Good Lord. Because I changed the problem so it would work out correctly. Change this. Well, now hear me out. You want to know why I'm changing it? Look what happens. How am I going to get that to be 1? I I can. How? Divided by 9. If I divide that by 9, all is happy, right? I get a 1 down here. But can I divide 4 and have the 4 cancel out? No. So this is why I changed it. Don't panic. We'll just fix 2 little things. So scribble. Scribbly, scribbly, change this. And I really meant to tell you about it before we started, but I totally forgot about it. I got really into my topic. Now, you're going to change this, stop, to a +4. And you change this to a +4, and this to a +4. And then this, nope, well, yes, a -4. Thank you. And so this becomes a -4. Stop it. So now, instead of 9, what do I really have?
6.
So now I really have a 36. Paper over here.
Oh, never mind. I thought.
Do you see now why I changed it? Okay. So next step is I need to make sure this is 1. So I need to divide that by 36, this by 36, and this by 36. So finally, what do I actually get? X minus 2 squared over, what does this divide out? 4. Nice, happy, perfect square. Plus, this cancels out and gives you what? Equals 1. So this is my equation I'm working with. That was the hardest part of the whole thing. What's your center? 2, -1. So plot that. Now, is my major axis is going to be vertical or horizontal? Why? Because your bigger number is underneath the y, your a squared is actually over here, right? So that's how I know my major axis is going to go this direction. So I need to find a. What is a? Square root of 9 is 3. So I'm going to go up 1, 2, 3, down 1, 2, 3. We could list those ordered pairs off to the side here, vertices. So those ordered pairs are 2, 2, and 2, -4. And then I'm going to find my other vertices, right? What's B? 2, square root of 4 is 2. So 2 to the right and 2 to the left. So this vertex is what? 4, -1. And 0, -1. So there's my 4 vertices. I can sketch in my ellipse. Am I missing anything? Again, this is kind of a fat ellipse, isn't it? Yes? Whatever I do to one side of the equation, I can do to the other side. And so essentially, I'm dividing the whole side by 36. When I divide the whole side by 36, I divide each individual one by 36. Same thing if I multiply both sides. So if I only did it to one side, then I can't do that. Right, wouldn't be balanced. So what am I missing? My foci. So step 4 would be foci. What do I have to know for foci? So c squared equals a squared minus b squared. What's your a? 9, and your b squared, 4. So if you get a negative on this, then you put them in the wrong order, right? However, c squared is equal to a nice happy number called 5. When I take the square root of both sides, I don't get a happy answer, do I? C is equal to the square root of 5. So here's how you're going to handle that on your graph. So the square root of 5 is about how far? How big of a number is that? Just estimate it. Well, you can estimate it because you know that 5, to the left of 5, the perfect square is 4, and to the right is 9, right? 5 is very close to 4, isn't it? So it is like 2.1. Well, I am not going to look at your graph and go, oh, no, that looks like 2.3, and I'm not going to mark you off for that. So if you just put it in between, if you just want to go up because this is approximately, make it 2 point, I mean, if you really want to be specific, it is 2.1. But if you said 2.5, fine, make it just right in the middle, because it's not that big of a deal to me. So we're essentially going a little over 2, right? Up, because we're a vertical major axis. So I'm going to go 1, 2, and a smidge over. So if I were you, I'd put it right in the center. And then label that F. And then 1, 2, and a smidge over, right in the center. And label that F. But here's the deal. You've now got to name that ordered pair. So your foci ordered pair, for this one, isn't it to the right 2? And then from the center, if you have not a nice happy number here, start from the center. Wasn't your y value on your center -1? Right, from here, and then from here, didn't we add the square root of 5? So can't I write that as an exact answer? 2, comma, -1 plus the square root of 5. Do you see why I did that? This is the only hard part about the foci, is if it's not a nice happy number. Bless you. And then for this foci down here, it's still +2, but from -1, didn't I subtract the square root of 5? I went down. So that's how your answer is going to be for your foci. Don't break out the calculator and give me some decimal answer. That wasn't so bad, was it? One last one. This time you're given the vertices. Now they only gave you 2, so what vertices? Oh, thanks, eccentric. Good heavens. Eccentricity. How could we forget? E is equal to C over A, which equals what over what? Square root of 5 over A is 3. Can I leave my answer that way? Absolutely. Am I going to try to figure out the decimal answer to that? No. Definitely not without my calculator. So that's why you'll see me leaving that one that way. But it's about 2, isn't it? Divided by 3, which is about what? 0.6. What was the one that we had before? 0.6. And aren't they almost equally fat? Because the axes are almost the same lengths, right? They're just like one off from each other. So you see that eccentricity is about at 0.6. Interesting. All right, so look at this one. Your vertices are 5, 0, and 5, 12. You can assume that they gave you which vertices? The major axis vertices, right? So these come from the major axis. And then they give you the minor axis. How is that handy? What does that 10 equal? This is the whole distance of the minor axis. Yeah, but that equals 2b, right? And so b, whoops, b, I can write it, is equal to 5. So that was handy, because we need to know what b is so we can square it. Now, I'm going to plot those points. So I've got So I've got 5 to the right, and then up. So one of my vertices is to the right 5 and up 0. Then my other vertex is to the right 5, but up 12. Eyeball it. Close enough for government work. So here's what I would like to do. I'm just going to put in here, normally I wouldn't do this, but I'm going to just put in a little dotted line in here. What do I know is on that line? The center. And where exactly is the center? In the center, right? What's the distance from here to here? 12. So because I can look at my graph, and I could have subtracted these, right? I could have subtracted my y's. So from this, I know that 2a is equal to 12, and so a is equal to 6. So all I have to do is count 6 up right here, and that's my center. So my center becomes what? 5, 6. That's going to be important to writing my equation. So do I need anything else in order to write my equation? Do I have all the information that I need? Do I need the foci? No. Could I find it if I wanted to?
Yes.
Sure. Does it say to graph anything? No. Now on my notes you'll see that I went ahead and graphed the whole thing. If you want to pull them up online, that's fine. But for our purposes, they are just asking for the standard equation. So right now, can't I write x minus over something squared plus y minus, got the y in there that time, you should be happy, proud of me, equals 1. Kelsey, I don't see you giving me some good vibes here. So my center, totally ignoring me. The 5 and the 6 go in the x and the y. And then because I have a vertical major axis, you have to pay attention. Is this a squared or b squared? Vertical means it's going along the y-axis, right? So my a needs to be going underneath the y. So my a is 6, and my b is 5. So now finish writing it. X minus 5 squared over 25 plus y minus 6 squared over 36 equals 1. Done. Aren't you happy we're not finding the equation of the line tangent to the ellipse?
Yes.